I'm sorry about that, ladies and gentlemen. That was... took me longer than expected. Okay, thank you for sticking around. Okay. So, I'll have to make this a little bit shorter, today's lecture, because I will still make it for the 3:30. Yes, OBS. Looks like there was some settings that changed. It disconnected my microphone. But let's talk about MAE 106, Discrete Mathematics with Probability. This is lecture 28, and we're going to talk a little bit more about Bayes' theorem. Again, we have for next week is test 3. What I was saying when the microphone wasn't working, we'll say that this is the 26th of November, so that's next Friday during lecture time. It'll be the same format. We'll be doing this over Zoom. Okay, if it's blurry, just make sure that you check your resolution. You just click on the little gear, and you should see some different drop downs for the resolution. Okay, so we're gonna do this over Zoom, and we're going to be covering the materials that are in lectures 18 to 28. This is inclusive, and it will cover assignments 7 to 9. Inclusive. Okay, now we had talked about Bayes' theorem before. We had talked about things. Okay, yes. I will check my email then. It's something must have, David, that's just mentioning in the chat. Yes, I will check that email for that. So over here, let's say that I have, here's my cause. We were talking about effect earlier, but let's say that there's a cause or something in the middle there, another event that occurs, and then we also have an effect. We can actually still apply the same kind of principle for Bayes' theorem to this. So again, we can create a probability tree. So I can say, oh, I have the cause here is E, or the event E. Over here, what I'll do again, I'll branch this off. So you'll have a chain. Oops, let's clean this. Okay. And then again, over here, we'll have G. Okay. So now what happens is we see, say, effect G. So for instance, we want to maybe come up with the probability of seeing E, given that, or E is the cause, given that we saw G. So what we want then is the probability of E and G all over the probability of G. Okay, so what I'm going to do now is I'm going to label this. But what you'll see here is, okay, so here is this would be the probability of E. This would be the probability of F given E. Over here, this is the probability of G given E and F. Okay, so if you multiply those together, times the probability of F given E times the probability of G given E and F. What this gives us is the probability of E and F and G. Same thing over here. This would be the probability of E and F and G prime. So I'm just going to write these all out. So as I follow down this path, this is F prime and G. This is E and F prime and G prime. This is E prime and F and G. Okay. So let me just label these. So I have, there's 1 branch, 2, 3, 4, 5, 6, 7, and 8. Okay. So in this case, I want to have where the events E and G occur. Okay, which means that I look down here, I need to make sure that it's E and G that are occurring. So in this case, it's along here. So here I'm looking for E and G. So here's E, and this is the first one. I have E, F, and G. So that's branch 1. The other one that I can have is E, F prime, and G. So that's plus 3. Okay, and those are the 2 possibilities where I have E and G. Now the next one for the denominator, what I want to do then is add up the ones where I have G. So in this case, I'll use just a different color here. So I can kind of go down here, and this is where G occurs here. I have a G here, I have G here, and I also have G here. So this would be branch 1 plus branch 3 plus branch 5 plus branch 7. So again, we could just write this out in full. This would be the probability of branch 1, which is E and F and G plus the probability of branch 3, which is E and F prime and G. So again, E and G, but there's the two cases where you have F and F prime. And then over here, you would have the the 4 cases here. So again, branch 1. Here's branch 3. Plus, and then you have branch 5 to worry about. Plus branch 7. No, I don't want to have that prime out there. Okay. And just as a visual check, I want to make sure that I'm just the probabilities of G. So again, G, 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 G. And basically we have all the different combinations of having E, E prime, and F prime. Okay, and same idea, you can do this for any other. If I said I wanted E given a different, let's say G prime, this is the probability of E and G occurring. Sorry, G prime, all over the probability of G prime. So again, you would just go and look for all the ones where you have E and G. So this one would be 2 plus 4 all over. Is it best to always do a tree? I am more visual, so yes, I tend to draw out trees because then I can see the consequences of doing one event affecting another. But if you're good at memorizing formulas, then yes, you could use it that way as well. So is it the best way? It depends on your personal preference. Okay, perfect. So then down here, you would have 6 plus 8. Okay. Okay, so let's do the example. Let's do just 1. We'll do like E and F again, kind of. In this case, we'll do, we'll talk about the World Trade Center attacks. So over here, we'll say that E is a plane hits a building. In Manhattan. And over here, this one is that it was a terrorist attack. Okay, so as we start with this, what we'll say is that we would expect that the probability of this being an attack to be quite low. So we'll say that kind of on a given day, it's quite low. We'll say 0.0005, so less than 1%. So this is low. What else would we consider? So what this is saying is that probability of an attack, again, without further information, on any day is low. Now the next thing that we can do is, what about the probability of plane hit, given that there's a terrorist attack, and we'll say that this is almost with certainty. So what this is saying, probability of plane hitting, given we know there's an attack. Okay, so what I should be doing as I'm describing this to you, let's draw our probability tree. So just to help us keep it organized. So here's our event. We have E, and over here we'll have F, and so we'll have 4 cases to consider. So over here, here's the probability of E, here's the probability of F given E, here's the probability of E complement, here's the probability of F given E complement, over here the probability of F complement given E complement. Okay. So now I can start to add in my information. Oh, and I forgot to label over here. All right. So let's look at something that we could oops, I skipped one. And so basically our question then is we want to know what is the probability of yeah, I know the lag is really quite bad today. Okay, so what I'm going to do is let's talk about let's change this order. And the reason because is I want to have it more as like an attack. Renew the browser and you'll get rid of it. So let's change this, because what I want to do is I want to use a cause and effect. And I switched them by accident. So over here, let's say that this is it's a plane hitting, and this is a terrorist attack. Okay, because now what we have is here is the cause, right? And over here is the effect. This makes more sense for us, right? So again, a plane could hit and it could be an accident, but it may not always be caused by this, right? So there's an effect. What we'll say then over here is that the probability of an attack is quite low. So we'll call this E. And over here, we'll say the probability of a plane, given that we know that there is an attack. So again, we'll switch this. We'll say that this is E, and over here is F. So now here's my cause, here's my effect. The cause is quite low, so an attack occurring is quite low. This one is a probability, and then over here is not. We'll say the probability of a plane hitting is quite low, given that there is an attack. Okay, so this makes a little bit more, just changing the letters, just to make sure that this is making sense. So then over here, I have quite a low probability, so I can label this on the diagram. And then on the complement, we just know that it has to be 1 minus that, right? So that is 0.099995. Okay, over here, that's equal to 1, which means that this is equal to 0. And the last piece of information that we need is something about when there wasn't an attack occurring. Let's say, how many times was there an accident? So one to many nines. Yes, but it's quite a low. Oh, sorry, over here should be 1. Oh yes, okay, there we go. Let me just clean that up. So over here, let's look at the probability of E prime and F. Over here, this would be E prime and F prime. But let's look at this one. The probability of F given E prime. So what this is saying is the probability of a plane hitting given it's not an attack. In other words, you could say it's an accident. Accident. Okay, so we can just look back in the history, and basically over 25,000 days of kind of the history of New York, there was only 2 times when an airplane had hit a building. There was once where a plane hit the Empire State Building. And I don't mean during King Kong. It hit in 1945 during the war, I think. And then the following year, another plane hit on 40 Wall Street. So there's been 2 times. So that gives us the probability right there. So over here, that's roughly 0.00008. So again, it's a very low probability, which means that there is no plane hit and there's no attack. Gives us a really low number again. So if we do 1 minus that, 0.00008, again, it's like was it a plane from our side? If the plane was on the other side, could it? I don't know. It's a good question. Let me just type. Okay. So over here, let me just get back here. It's 0.9992. Okay, so now what we'll do is we have all this information. We can calculate this probability. So what this is saying is, what is the probability that it was a terrorist attack given a plane hit? And that's what this means. And so we can calculate that. So let's do it. It's the probability of E and F. So both of these occurring over the probability of the given. Oh, apparently there was another. So we'll. Okay. Incident in 2006. Okay. That's good to know. So another one in 2006. Let's update that then. So that would be 3 over 25,000. So that works out to, oops, I'll switch back to my orange. 0.00012. And then if I do 1 minus that, 1.00012 gives me 99988. Now again, this would have happened after 9/11, and this would be a little bit more days then. So we should have actually changed this number then to reflect that since 2011. So anyways, quite a low number still though. So to do this, what we'll have to do is we do the, I'll just label these, branch 1, 2, 3, 4, which means that I need to have the probability of E and F happening. So that's branch 1 over branch 1 plus, and the third branch here, because this is where F is occurring. So that's 0.00005 all over the branch 1 again, so 0.005 plus the third 0.00012. So that should be, let's see, roughly 5 plus, so that's 17, 5 over 7, 5 over 17. Hopefully I added that up correctly. Can someone double check that? Yes, okay, perfect. So this is kind of what, I've added or changed a little bit of this information here because of the 2006 one. But basically, yeah, because there's 5 plus 12, so 5 over 17. Okay. So that's kind of what when we were watching this in real time, when somebody told us that a plane had just struck the trade tower, the probability that it was a terrorist attack, it kind of went up. It went up from a really low probability of less than 1% to, well, it's getting close to 30%. We didn't know at the time. So that's kind of what happens when we get this new information. So what we had here was our probability of a terrorist attack happening that day went from low 0.00005 to around 30%. So as you saw, we can, it's all dependent on what kind of information that you have available to you. These are some things that we might have to calculate or go back into our history books or something like that to help us come up with our initial estimates. So over here, you'll hear people say that this was, and maybe I'll switch back to just using decimals, point. Over here, this is what we would call our prior probability. And over here is called our posterior probability. This is what we start out initially, and then to get here, there was some new information. So for instance, we went from here, this was a terrorist attack, we saw a plane hit, and then updated our probability from something very low to something a little bit higher now. And that's what machine learning is about. Machine learning uses things like this in the sense that it'll have a probability of identifying something, it will collect some new information, and then it adjusts its probability accordingly. So again, over here, this is just over here, this is what we would call like our starting or initial probability. Okay, thank you everyone for tuning in on this Friday afternoon, and I hope your day goes much better than my equipment here. Thank you for hanging in there. If you have any questions about the Bayes theorem, please send me an email at my RMC account. Also, check out the textbook if you need some more clarifications. There's some exercises. I would recommend, after looking at this one, that you try something like looking at try exercise 8.11.1. Have a good weekend, everyone. Take care.